Oh, hi Sri.
Hi, Sanjay.
So welcome. You've been here before. This is my lab. This is one of our charger PCBs. It's very messy here. The office is supposed to be the clean space, but we are doing most of our work there right now, the firmware programming. So welcome here. And this is our setup here. So that's our logo there on the wall. And we have got one of our brightest engineers sitting here. A few others are also around somewhere. And one is in Germany, as you might know. But we are focusing on what we are doing here. So this is, let me introduce you to this. This is our transmitter board with two coils. It can be used for edge charging. So this is a receiver board with a meter attached, so you can see how much power you're getting. Then here you can switch over to laptop, lamps, or a combination. All the oscilloscope waveforms are coming here. This is the power supply. This is a current lamp. There's a laptop, HP laptop, which will charge. And this is another power bank where you can attach the coil on the side with our transmitter board. And just to give you an idea, if I put this here, you will see the red light has gone up. That is our foreign object detection. Okay, so it's all active and it goes back. It knows I have removed the coil. Okay, so that is it. And there are a lot of waveforms here which I'm not going to confuse you with, but our code is right there for the firmware. And I know we have a code for the receiver also somewhere, which should show up in a minute. So because of COVID-19 times, we are trying not to look over each other's shoulders. And we get a lot of work done this way. So it's a working engineer setup what we're going to show you. This is the code, and it is extremely complex. Can you show us how many lines of code are there on this? Okay, so somebody is going to scroll here, and this goes on to, I think, 4,000 lines or something, 5,000 lines. It's the STM32 project, as you can see. Now, if you look at the screen there, it's actually showing you three things. It is showing you the frequencies. We do 3 pings, and you see the frequencies are very close, within 250 Hertz, which is our resolution at this point, which is enough for this purpose. But we are improving that also. So the 3 pings are in real time giving you 3 identical frequencies which you expect, so it's noise free. Now if I put a coin here, this is a coin, watch the frequencies change as I put this. You saw that changing? That's part of our patent, and if you look closely, our FOD light will go on as I showed you. Okay, so this is what happens with our intelligent tracking. This is our frequency. On the right side is the receiver code in a particular RX mode in which there is communication and all sorts of things. It's a cheap microcontroller which you can incorporate in an HP laptop or tools or phones or whatever. That is a one-to-one mode, whereas we also have the general purpose mode, which is shared mode, and you can see this is active, fully active. This is about 20 watts, and you can actually put, now if you do something very fast, you saw the red light come on, that's our FOD proprietary. We have many levels of FOD, so it went back saying it's okay, and you can actually put multiple receiver modes. So you can see there are many modes here. So this is one of the modes. We also do Qi, dual Qi, which we'll demonstrate at some other time. So this is a power bank, and you can use it to charge a laptop in our one-to-one mode, which gives much higher power. And here you are seeing some sweeps here, and I'm going to start explaining to you what we are seeing here. Okay, so first we are going to show you a 12 volt CE-RX mode, which is the 1-to-1 mode. This is 20 watt lamp, LED load, and the waveforms are all there, and you should also look at the screen there. There are a lot of values coming out there. Can you scroll up and show me the frequencies? Okay, these are the three ping frequencies, which I told you are very similar within 250 Hertz, in fact exactly identical, and this is basically an open frequency system. So we are the only people which actually track the resonant frequency. It's in kilohertz. So it's 131 kilohertz, well below the 150 kilohertz EMI region where the testing starts. So we are in a very safe region. And it's continuously sweeping. So it is constantly updating. We're not doing anything to the cursor. This is a live update going on. It is running through this Discovery slowdowns. This Discovery microcontroller kit is connected to it with a lot of wires, and it's going to our brilliant engineer's laptop here. Okay, so that's what we have. And now we are going to show you that this receiver, which is actually very simple, it's just configurable for lab testing. It's got a simple coil here, you know, our proprietary receiver coil, and we put a meter just to make it stand, and so you can verify that we are not playing tricks with you. And there's a current clamp here, which is, by the way, this one, and it is on the 100 millivolt scale, so it'll be 1 ampere per vertical division. And we have connected this to this, which is our 12 volt lamp, but this is now coming through our 1-to-1 receiver board, which the earlier one did not have. This was the simplicity of the earlier one. It had a simple coil, that's it, and it can support multiple modes, but we keep it at low power. For high power, this is the recommended one for tools, laptops, phones. All right, so I'm going to put the coil next to it, and I'm going to also focus. I'm going to start my camera, and I'm going to start showing you what happens to, this is a separate camera, and I'm going to focus more on the meter here. And you can see the screen here, which is updating. And now watch how the frequency will change as I place my coil close to this transmitter. Okay, you see the lights change. It detected it right away. It does a reset for various reasons which I don't want to get into right now. It's to reset the microcontroller, and then it has started in full intensity. Have a look at the frequency. The switching frequency has moved up to 136 kilohertz, and you expect the switching frequency to move as a function of load, which all the others didn't seem to understand. The phase is 445 out of 1000, which is 44.33%, right? Yes, it's only 4% because of the light load we have. The input, as you know, is 15 volts, and you can see it's regulating at about 12 volts. It's about 20 watts, and this is the input. Okay, so for a tiny coil with very low coupling, and if I move it, the brightness will still be maintained, by the way. So I'm moving it, and the brightness is still maintained.